Okay, so it's now recording. No, don't be silly. So, the purpose with the elimination methods is that you get either you keep the equations as they are, and then you get the number of x's or the number of y's the same, and you don't have to worry at this stage about whether it's positive or negative. Okay, so you have to do something to the equations to get the same number of x's or the same number of y's. There are a couple of suggestions. Who can make a suggestion as to what options we could have to make the same number of x's or the same number of y's? Angus?
You could find the thing they both go into.
Yep, so what are you going to do?
You could times the 4 and the 2 together to make 8.
Yep.
They both go
Can't you
into 8.
get
Yep.
both 4?
And if they both went into 8, and therefore you times the top one by
8. No, 2, sorry.
2 and the bottom one by
8. No, 4.
4, and you get 8. Yeah. Okay, so you could do the top one by 2 and the bottom one by 4. That would give them both have 8x. Yep, absolutely brilliant. Anyone got any other suggestions? Because that's not the only way. Yes?
Times both of them.
No. What would you do? Because
Times 2.
yeah, times the bottom one by 2. I think that's the easiest way. There is one other way that you could do it. Yeah.
Could you divide the top one?
Yeah, you could, but what's the problem with... You could do that, but what's the problem with doing that? Yeah, you end up with decimals, which is just horrible. So we try and avoid decimals, but you could do it.
Yeah.
Yep, absolutely. The other way you could do it, you could multiply this one by 5 and this one by 3, and that would do it as well. Okay, but we're going to do Cecily's way because I think it's the easiest, yeah? And I'm just going to write down here, I'm going to do equation 2, and I'm going to multiply it by 2. So I'm just reminding myself what I'm doing, and I'm going to write down that is 4x minus, help me out, 10y equals 26. Okay, so I've now got these two equations, and I'm just going to write them down. I'm going to call this one equation 3, and I'm going to rewrite equation. Okay, so now I've got equation 3. Okay, and I've still got my equation 1 there. So I've got two equations that now both have 4x in. Are we happy? Okay, apologies. Yeah. But can you see we've got x is the same. Now this is where elimination gets you quicker to that equation with just y's in. We need to do something to both equations that will get rid of the x's. So what can we do between equation 3 and equation 1 that will get rid of the x's? Cameron, I think, was marginally first. What do you think?
Just minus 4x from both.
Yes, but that puts it to the other side. We can actually do something to both equations, combining them together in some way, that gets rid of not brackets.
Make it how you make it in this.
No, you won't have seen this before unless you've seen it. So I'll have a go. So what you do is you can subtract. Take equation 3, and you subtract equation 1.
Wait, what?
Okay, so this is the revolutionary bit. So 4x minus 4x will give you 0x. Minus 10y minus 3y minus 13y. You happy with that?
Yeah. No, wait.
Yeah.
Oh, yeah.
We have to use this way.
No?
And then you got.
If you get the other way,
I know the other way, and this way is confusing.
okay, that's fine. But I am showing you because if I don't show you, then some people will go, oh, there's this other way. It's called elimination. It's way easier. And Mr. Goodman never showed it to us. And why didn't he show it? Yeah? Okay. Minus 13y. And then you've got equation 3 minus equation 1. So 26 minus 39.
Yeah,
Minus 13.
No, so wouldn't it? What, you don't get 26 because that's equation 2.
No. This is equation 3 because this is the one that's been multiplied.
What would happen if you got given? Shut up, okay? I don't get this.
Yeah?
I get
Yeah. Can I just go to the end?
I mean, if this gets posted on YouTube.
So
Minus 3 or no? Could you do equation 1 minus...
yeah, you could, and then they'd end up with all positives. Okay, Sashin's were spotted that actually it would have been much nicer, and I've deliberately not done it the nice way to begin with. But you can see if I'd done 1 minus 3, I'd have ended up with much nicer numbers. But it still works. 3 minus 1 is 26 minus 39, which is minus 13.
So y equals 1.
Which means minus y equals minus 1, which is y.
And so what have I got to divide by to solve this?
Minus 13.
If I divide by minus 13,
Then you could skip a step.
I can do it in one go. Y equals 1.
I am very confused.
Okay. If I then I then need to find out what x is, and this is where this method is slightly slower at finding what x is. I now have to use equation 1 to find out what x is. So equation 1 says 4 times y plus 4 times x 4 times x plus 3y, and y is 1, equals 39. Okay, so I've now got 4x,
Why do you do 3 times 1?
because y is 1, and I'm just using the top equation, equals 36. So then divide by
7.
4.
Well, it's 7. X is 4.
X is
Yeah.
12.
No.
No, it's not.
4's into 36, go
12. No, what? How have I got 12?
9.
Sorry, that's
9. Thank you, Debbie. Yeah, 9. And now I can check that this works in the other equation.
It does.
In equation 2, 2 times x, 2 times 9, minus 5 times 1. 18 minus 5 is 13. Tick, check, and I know that I'm right. Okay? So this is the same equation, but I'm going to do it the harder way so that you can see how it still works if I do it the harder way using elimination still. So
slow it down a bit.
I've got equation 1 and equation 2. Yep. I'm now going to multiply equation 1. I'm trying to get the y's to match up. So I'm going to multiply equation 1 by...
2.
No, I'm going to get the y's to match up. No.
5.
5. Yeah.
Oh.
Yeah, and then I get
2 by
20x plus 15y equals, and this is a bit big, but 390 multiplied by 5 I think is 190. 190.
Wait, 100.
190.
How is it 190?
No, 195.
No, it is 190 because... No, it's not
195. It's 195.
195, sorry.
Yeah.
Check the time.
195. Okay. And then number 2, I'm going to multiply it by 3. Okay, so we're on that now, and we can see that we're going to get 6x minus 15y equals, multiplied by 3, I can do that one, 39. Okay, so I'm going to now label this equation 3 and this equation 4. Now, here is the difference between this method and the other method, and this is the key thing that you need to pick up. Okay, I've got 20x plus 15y equals 195. 6x minus 15y equals 39.
That's wrong.
It's fine as long as I now do a key step. Okay, what do you think I have to do to combine those two equations to get rid of the y's? Yep, and how am I going to cancel them out? Cecily? Yeah, yes.
Add them together.
Add them together. If I add equation 3, you remember last time we subtracted them, and this does what we were saying here. If we add equation 3 and equation 4, 20x plus 6x is
26.
26x. look at this. Plus 15y
Minus.
plus minus 15y gives you
Still that.
no y's. Plus 15y, and then you add on minus 15y, you get no y's. Yeah.
This is different to the original method you taught us as well. Isn't it? I think I just prefer the original.
Yeah, that's fine.
Yeah, but
That's fine.
Keep it OG.
And then let's keep going. 3 plus 4 is, add this together, 4 and 1. 10. Sorry, that's 14. 9 and 3 and 1 is 13. So 2, 3, 4. If I then get x, I've got to do a bit of division here. 26 is into 2, 3, 4. I get my calculator out and I do that.
260 is 10.
Many.
So
Yeah. So it's going to be 9.
I think that's an easy.
Yeah.
I think that's
Cool.
the way
Yep. You might have seen this before. I've then got to get what y equals, so then it's back to the same method that they all use. So I've got to substitute this into equation 1, and I get 4 times 9 plus 3y equals 39. 4 times 9 is 36, so I've got 36 plus 3y equals 39. So 3y, take 36 away, 3y is 3, so y is 1. And if y is 1, then I can now check that that works in equation 2.
Sir, for the bit where you plus 3 and 4 and you put and it says 26x equals 23 and then
234, 234.
Oh, 234.
Yeah, sorry.
Oh,
Yeah.
okay.
So check in question 2, sorry. And so I've got 2 times 9 minus 5 times 1. 2 times 9 is 18, minus 5 is 13. Check. I know that I'm right.
Yay.
Okay.
I like this method.